Okay, in this video, what we're going to do is we're going to go ahead and take off where we left off, where we looked at this capture callback. We were getting into the callback, it was happening. We had these last and current values, and we were able to essentially compute the period. And this is happening all the time. And so what we want to do now is let's look at these values, and I'm gonna look at them basically through the debugger as opposed to trying to print them. And definitely, of course, in an interrupt handler, you would never want to print in here, right? Because if you start doing things that are really heavy like printing, you'll start missing edges. And so remember, this capture callback, we are still in the interrupt handler, right? We're being called from the interrupt handler. So we are still effectively in that interrupt handler's call stack. And so we don't want to do anything that takes a long time, like, say, printing. So we can set flags. We can update variables that are global. There are a lot of things we can do, but don't print. That's relatively painful and large. Okay, so what I'm going to do is I'm going to come over to main, and I'm going to create some variables here. And so I'm going to add a variable up here. I'm going to add a couple of variables. I'm going to call them volatile, float, and TSL237, clock period, and I'll get this first part here. So a period and a frequency. And I'm just going to use floats here now. You know, I would generally, in a system like this, I'd probably use fixed point just to avoid, leaning on the... I wasn't actually showing you that. All right, so I added these two variables here. I'm just adding them to main. I made them volatile because what I don't want is I don't want the compiler to remove them because they're not being touched. And in this case, the compiler actually would not remove these variables because of the way I'm going to modify them. But in general, when I'm working around variables that are that I'm touching between the interrupt handler and the, I just want to make sure that the compiler knows that. And in fact, I'm going to come up here and I'm going to make that change to this period variable here, so that the compiler doesn't optimize it away when it doesn't see an obvious way that variable is being modified. All right, so I'm going to come down here into the while loop, and what I'm going to do is I'm going to add a how delay. I'm going to delay just 100, and I'm really just doing that so that I have something for the thing to run for a little bit, then I can stop it, and then I can look at what the period variable is. So let's go ahead and just build that, see what we get. Yeah, it's not going to like the fact I didn't use those. That's fine. And so for now, that's okay. I need to go through here and kill off some of these breakpoints. I'm going to put a breakpoint right here. All right. So the interrupt, remember, even when I do a delay here, the timer's going to be going off. It'll go off several times. So I should get an update to the period variable. And so let's go ahead and run this. So into the expressions, I've got this variable period. And so I'm going to run it. And so I'm getting a value that's like 68,393, somewhere in that neighborhood. So that's my timer capture value. And it's going to move around as if I were to, let's say, I can show you here on the scope. So if I were to take my hand and really kind of cover this over here, come back over to cube, and I were to, run it again, the number starts to get kind of big, right? Because remember, these are ticks of the counter, right? So the counter is running at some rate, and that rate is then um, that rate then determines how fast it counts, and that so the count then basically what we're getting is a period, right? The interval of those counts gives us, in the number of the counts that happen, tells us what the period is, and from the period we can get the frequency. So let's go ahead and make that computation here. And so what we need to know is, well, how fast is that clock running? And so let's come into here and let's TSL 237. Let's go ahead and compute the period here. And I'm going to come up with a constant here. Cast as a float here of the system core clock. So it just so happens that I am running my clock with a my counter, timer 2 counter, with no divisor off of system core clock. So it is running at the rate of system core clock. Now, system core clock is a variable that gets loaded when way up here when you do this how init, it loads this variable. This is a global that allows you to determine what your clock frequency is. So I'm going to take this, I'm going to multiply it, cast it, times our period. So remember, our period is in terms of counts right now, our variable period, right? Because remember, we just did that simple computation to last, minus current, that sort of thing. We did that, current minus last in the sort of nominal case. And so we've got this number of counts, so we want to turn that into a time. And so this would give us the time and then our period here. So this is number of ticks times how much time each tick takes, which is 1 over the system core clock, and that'll give me the actual clock period. So let's go ahead and see if this will, I'm going to stop this, and then let's go ahead and build it. It doesn't like the fact that I set it, but I didn't use it. That's okay, because we're just going to look at it. Okay, here we go. So go ahead and run to that breakpoint, run it again, just to make sure everything's up and running. We'll go look at our variables. And so my clock period here is 0.002. So it is around 2 milliseconds, and so that's gonna vary depending upon what our actual frequency is here. And so if I were to go over to my scope, it's telling me that it's around 2 point something milliseconds, and so it's in the ballpark. And this is going to be pretty darn accurate, but just for one cycle, right? And so this period here is doing it. It's giving you some statistics, right? This value here is filtered, so this is probably going to be a little more accurate on the aggregate, but in the single shot, this is still pretty accurate. Now, if I wanted to, I'm going to go ahead and shut this down here. If I want to go in and look at the clock frequency, I should bring up my Q by E here. Clock frequency equals just 1 over that. That's just the nature of the reciprocal nature of frequency and period. So now when I do this, it's going to still complain that they're set but not used. That's fine. Go over to I made them volatile so they don't get removed. You don't make them volatile. Sometimes the debug, depending upon what you've got your compiler set to, what an optimization level, sometimes it'll just strip them out and they'll just be gone. So I'm going to run this a couple times. And so our frequency is somewhere around 484. So if we come over to the scope, you know, that's in the ballpark here, 480, around that. So you can basically see that, yes, we are indeed measuring this frequency. Now, in the next video, what I'll do is I'll come back and I'll show you, okay, well, at least in the application of the light sensor, we don't need this thing chewing away all the time. We don't need it. We want to make a measurement. We'll make a measurement and then we'll turn off the interrupts. Because what we don't want to do is when we're in a power managed environment, we don't want to be just creating zillions of interrupts that we just don't need. We don't want to be woken up that much, right? So we only want to, in fact, we're gonna learn that we're gonna power that light sensor down. We're gonna take power off of it. But even so, we want to control when we get those interrupts. So we're gonna only when we want to actually make that measurement, we go out and turn on the interrupts, let it interrupt several times, 2 times to give us the period, and then we'll kick off the interrupts. And so we'll show that we can just build something that just turns that on. Now, what you'll notice is if you are integrating this into your code, your larger code that has printing and doing commands, you may find that your terminal interface that you've built becomes non-responsive if you don't limit the number of interrupts, right? If you're not getting 484 per second, let's say you've got the, if I take the tape off and I'm getting, 200,000 a second, you're going to find that you're not going to be able to communicate with it. It's going to act like the terminal's locked up. It's not locked up. You're just saturated with interrupts. So know that. So, okay, for next time, we'll look at how do we more effectively enable the interrupts so that we only get these interrupts when we care, right? Only when we're trying to make a measurement. All right. Okay, more next time.